All right, hello everybody. Um, I forgot to turn on one of my lights. I'm gonna go do that right now. How's everyone doing tonight? We're gonna be talking about all kinds of cool projects tonight. Where I am fully complete with my SparkFun Inventors Kit. I'm all done with that, and boy, was that a good investment of both time and the $100 that it cost me. I think it was a good call. It was a more expensive kit, but it did me some good learning. So I am joined today once again by Zenhaver, and Zenhaver is he's a very clever man. I would consider him very clever, very smart. He's good at electrical engineering, as that is what he does for employment. And a good friend of mine, and also getting more and more into making and building things. So just before we started here, he was telling me about some new 3D printer filament that he was getting. So welcome, Zenhaver.
Hello, good evening. Yes, 3D printing has been my pseudo obsession for the past 2 weeks now. I am getting my third roll of filament, which is going to be a beautiful marble color. The first thing of which I am going to try to print with is sort of an upsized miniature. So I don't know what you call
Oh,
that. A normal figure,
could
an
be
action
a
figure.
yeah, action figure. Could be a large size creature.
Yes, large size creature. I
Sure.
had tried some small test prints, and I do mean small, miniature sized miniatures.
Tell me, I have a ruler right here, actually. If you want to tell me about how tall they are.
They're probably an inch and a half to 2 inches tall.
So let's just see. Just so everyone remembers what a ruler is. An inch and a half to 2 inches tall is this big.
Excellent.
You can't. That doesn't work if you're viewing that on a TV
Yeah.
or anything larger than uh, cell phone, probably. But cool. That sounds awesome. Um,
Yeah, pretty excited about that.
I'll have to, if you are interested in it. I do have a an airbrush kit specifically for painting miniatures. If you were ever interested.
Yeah, I've toyed with the idea. It sounds kind of interesting to just be able to print miniatures arbitrarily and start painting them, but we'll see how far I go down the miniature path.
Hmm. Well, it's a short one at least, if it is
Yes, very
miniature
true.
path.
Excellent.
Um, yeah, I have. I kind of went on a bad. I had a bad run of Kickstarters where I kept on getting into Kickstarters that sent me miniatures, and I have probably 1,000 miniatures that are unpainted. Um, I'm actually hoping to maybe get that. I spent a bunch of time this week cleaning up my actual like studio that I work on, not my video studio, but my like craft maker studio. And I previously had a pretty nice setup for painting miniatures, and I think we might get back to it by January. So
Sounds pretty
maybe
fun.
I'll do some miniature painting at some point with that, which is so relaxing and so frustrating at the same time. So that's awesome. I actually have one of your works here. Thank you for printing this for me. This is excellent. This is a um, a PCB clamp that Zenhaver printed for me. You did an excellent job. I can see the toil and love made within this.
Yes, it
Um,
was a whole 3 minutes spent in Cura slicing it, and then maybe 15 minutes worth of keeping the 3D printer going, churning out those pieces. So,
was there much assembly involved?
no, there was three total pieces, the base and then two jaws.
Hmm.
Um, I did have to sort of, well, what's the right way to describe it? It was very difficult to get those jaws into that T track
Yeah,
to start off with, so I basically had to like force them in, and then just kind of keep moving them back and forth to sort of grind away or sand down some of the T track to make it more easy
sure.
to slide them back and forth. So I don't
So
know
this is
how
the
smooth they
T
are
track
now.
here that you can see. They're quite good.
That's good.
Um, I might add a little bit of silicone grease or something like that to them.
Yeah, I was gonna recommend that to you and then totally forgot. So yeah, a little bit of like silicone grease would be perfect.
Yeah, so that goes right in there. And then the clamping force comes from a rubber band. I only have really large rubber bands for some reason, so I had to I tied this one off to be a little bit smaller. And this was for one of my next projects. Not something we'll probably work on at all tonight, but one of my next projects is, sorry for the earthquake, is to work on this fun little keypad project. So this is a for a little macro keyboard that's Arduino based. I have all of the parts to it now, I think. I'll showcase some of the other bits, but with this in this little vise, it'll make it significantly easier to work on. So I did get some things in the mail for this project. I know I just said I wasn't going to do this, but goodness gracious. We have, so here at the Grant Makes household, we're totally adults, and not just, I guess we're totally normal adults who definitely have their TV on a cart like you would find at an elementary school. So we cart our TV around to various parts of the house, and so that recent earthquake was the TV being carted. It's quite handy, actually. It's really nice. So here we have some of the switches that will go on here. I have a whole box of cherry switch knockoffs here from a keyboard that got bezapped by a faulty USB hub. But all these switches are still good to go. So I have mostly MX browns. I have a few blues. Excited to add some of those. Ooh, and it looks like I might even have several blacks, which is cool. Or these are still just, these are just browns. They're just harder to see. So some different colored blacks. And these switches are knockoffs of the cherry switches. And I think, Zenhaver, you know more about cherry switches than I do.
I know about some of the old school cherry switches. There's been a real flourishing of different varieties in the past few years that I have not kept up on. So I know the basics, but if you asked me to describe some of the newer innovations, I would not be able to.
Fair. That is fair. Yeah, and these actually do fit in the holes just fine. So these are the switches that I'm going to be using for this project. Granted, if they fit properly, I think they all should. So I'm using these as well as the controller for this. Here is the this new board that I just got, which is the Arduino Pro Micro here. These things are deceivingly small. They are so itsy bitsy, I can't even believe that you can just buy these and then it's an Arduino. So is there any like difference between the Arduino Pro Micro and the Arduino that we've been using for these tutorials?
Oh, I'm sure that there are differences. Yes, this one seems to be lacking some of the power regulation circuitry that lets you power like the other Arduino with like 4 AA batteries.
Sure.
This one looks like it doesn't have, yeah, it doesn't have like that voltage regulator on it, so you have to power it via USB or strictly 5 volts.
Sure.
I'm sure that there are other differences, but
That's the most obvious.
mainly one of size.
So that's super cool. So I'm excited about this project. There are some good instructions on the larger version of this PCB, but I've since sent an email to the creator asking where the instructions are for the micro version of this PCB because he doesn't have any posted really. So I'm gonna wait just until I get a little bit more information from that dude. And once I have all of that, I think I will proceed with making this. So probably another couple of weeks if I had to guess, had to venture a guess, but eventually it will be a cool little thing like this. And you were talking about another 3D printing project you've done recently, right? You made some keycaps, I believe.
Yeah, I went through a few iterations making Cherry MX keycaps. The latest ones I do actually have on my keyboard right now, just
Oh, nice.
WASD. And they've been working
Cool.
out pretty well. They are slightly textured just by nature of being 3D printed, and the profile is a little bit different because I did not like how the actual curved keycaps were turning out.
Sure.
So these
Just
ones are
based on the
flat.
print fidelity.
Yeah, print fidelity. I was having a hard time actually getting the underside, the part that actually fits onto the cross, of the Cherry MX keycaps themselves.
Sure.
I was having a hard time getting those printed well.
Gotcha.
But yeah, and it let me do a little bit of painting as well to get them filled in and able to show up when they're being backlit, which was a real victory.
Excellent. I like that. And that's kind of cool because that was like your most high fidelity project you had done at that point, right?
Yes, they were printed on some pretty high quality settings, and I think they turned out pretty well.
What's your what's the how do you describe the definition of a 3D print?
I would describe quality purely in terms of layer height.
Layer height. Okay.
So that's how high on the z-axis the 3D printer will try to print each layer.
Okay.
So 0.2 millimeters is sort of the go-to, like I just want to get this thing printed
Hmm.
and don't really care so much about it being really crystal clear, smooth. Um, zero point 0.1 is about the smallest I would go.
I don't know if we can zoom in and out. Oh, we totally can with this microscope. Um, so let's see if this. Oh, it's not working. Come on, buddy. You can do it. Dang it. So sorry. Point two. You said.
0.2 would be coarse quality or like average quality.
Yeah.
And then 0.1 would be fine quality, like ultra quality. And then anywhere in between is yeah, gradient on how much you would like your quality to be. So
Are you able to go down to point one on yours?
I am able to go down to 0.1 on mine. Yes, that's what those
Nice.
miniatures that I showed you were printed at.
Nice. And this how about this vice? Is this vice on that scale, or is the vice on point two?
I believe I printed the vise on 0.2.
So when you're working on this, what would be a what's the time trade-off for going with point one instead of point two?
Well, it takes twice as long to print things that are at 0.1. It's pretty much a linear relationship, right? Like
Fascinating.
you think about a printer, how it
Yeah.
slices a 3D model into
Yeah.
a whole bunch of very thin slices, and that print head has to travel along a certain path for every single one of those Z slices. A 0.1 millimeter sliced 3D object will take twice as many passes of the print head.
And on the next episode of Grant Asks Stupid Questions.
It's fine.
um, that's awesome. What was it fairly intensive to get your setup configured in order to do the point one?
Yes, actually, it's taken a lot of tinkering and research on Reddit and such to be able to find out like I'm having this specific problem. I'm going to type in what I what I perceive the problem to be, and oh, there's a post on Reddit that describes exactly what I found. I'll
Is
fix
that on
this.
R first print or first layer or something like that? I think.
I have
The
been well, actually, I've been using a few different subreddits for getting
nice.
stuff answered. There's like the Ender 3 subreddit, and then functional print and just regular 3D printing
Cool.
subreddit has some good info on it. But yeah, it's been all sorts of little tricks and little things to tinker with to get it in a place where I'm happy with the quality.
I'm loading up SketchUp right now because I want to show you something on SketchUp. That's yeah, I can imagine because I know like working on I have a friend who has like a monoprice 3D printer and trying to get we were trying to get TPU to work, which is TPU is the more flexible filament, and it's just a bear. Just really trying to get that to function was a real challenge actually to be able to get that to work. So just like bed temps and extruder temps and all that kind of stuff is just it's a quite the balancing act. So kudos to you for sticking through that. Do
Yeah,
you
my
think?
I was just going to comment that my
Yeah,
understanding is PLA is probably the most straightforward and easy to use filament as far as like those sort of temperature and
yeah.
those kinds of settings go.
Would you be hard pressed to want to change any of your settings to switch to like ABS or some other kind of material?
I'm sure that in the future I would like to try because I think a
So,
lot of like the tinkering I've done with the actual 3D printer itself is just stuff that would need to happen regardless of filament type.
oh,
And
okay,
all of the different settings like in the slicer that would control like the extruder temperature and stuff like that to accommodate other filaments. I think that would be fun to explore.
cool. Well, that's great. Thank you for talking about that project you're working on and all of those things. So I'm excited to see more of your prints and probably request some more. So I'm excited to talk about this next project. This is what motivated me to get into getting the inventor's kit in the first place, and I think it's a really good candidate just for some potentially some collaboration with your 3D printer knowledge and expertise, and 3D printer along with that, um, and some of the electronic stuff as well. So I have a project that I've been hoping to design based on Kratky hydroponics. So I want to do some basically I want to grow vegetables in my house. So I want to be able to grow like lettuce and kale and some other stuff like that. Maybe some spring onions and an herb garden, because it's kind of dark and cold here, and it's nice to be able to grow some veggies and stuff. So I want to do a kind of like this, kind of based on a project I saw a friend of mine do where they made space lettuce. They had an entirely enclosed system that they grew some lettuce in, and so it'll all be in my basement, based on some shelving units, and I think I have a vague idea as to like what kind of electronics I'm going to need to manage it, and could definitely use your keen advice with that. So I've been doing a lot. I was just trying to switch scenes, oops, by pressing this non-existent keypad because my Stream Deck usually sits there. That's not built yet. I can't use it. Um, Whoops. So what I'm going to show you is, oh, I have both of these things. Cool. What I'm going to show you is my SketchUp model. So I'm a really big fan of Trimble SketchUp, formerly Google SketchUp, and just 3D modeling in general. So this is I built this week, put this together this week, but this is what I've been imagining for this project. And so there's some key features here. One, this is like your run-of-the-mill wire shelving. I use this stuff quite a bit, actually. I use this all over my house. In my workshop upstairs, I use this as my workbench, actually. So I have some counter height ones with tabletop kind of area, and storage below, storage above. So what I'm hoping to do is to convert the bottom of one of these shelves into a fully enclosed greenhouse. And it's worth introducing Kratky hydroponics as well. So Kratky hydroponics are ones that don't require any, you don't need any aeration or any fancy spraying of anything. It actually it just, as the plant drinks the water, the roots grow longer and longer, and that air that's available to them there is all the aeration that they need. So you can actually just stick, if you have the plant nutrient set up right, you can stick it in the nutrient, and as it drinks down, the plant will grow taller. And very seldomly, or in like 3 weeks time or more, you might have to refill it a little bit. I've done this a little bit, but the last batch that I did, I super killed everything with my water that has some salt in it. So I'm going to be using distilled water for this next project, and I think it'll work great. He said confidently. So that's why I don't have any pumps or anything like that in this system. There are some other methods of doing hydroponics that are just going to be a little more complicated. I kind of want to keep it a little bit more confined for this particular job. So the key electrical components we have here are the lights up here. And so when you're doing any greenhouse work, you want to have simulated daylight, which means you don't just have the lights on all the time. The plants need to rest a little while. And hey, Chef Rex, you grow super hots in my basement. Nice! That's awesome. I should grow some of those too. What's your, do you do Kratky or a different method? So you want to have the lights on and off at certain times. So I'm going to do, I think I was reading online 16 hours on, and then 8 hours off. What is that? Yeah, 8 hours off, 16 hours on, 8 hours off. So it'll cycle regularly on there. It is cold in here, so I have Good old fashioned water, soil, light, and air. Weird. That sounds great and way more predictable than what I'm doing. So, um, that's cool. I've been thinking about trying that, and with this method too, I could just try some soil pots. That's probably a good idea, just as a bit of a control. Then I know if it's the temperature or the Kratky method. I like that. Thanks, Chef Rex. These are some heat mats. There's some like seed starting heat mats that are fairly low current, that don't take very much at all. And so these would be down here, underneath the jars. And additionally, I have a fan at this top up here. I'd probably do just a PC case fan that I have kicking around. And then I would like to, if I feel like being overly clever about it, more so than I already am, limited verticalness. What do you mean, Chef Rex? I would adjust the lights here based on how tall the plants are. I'm not convinced that this is a good idea. I'm not sure, just based on the accuracy of the sonar sensors that we were playing with before. Here in the starter kit that's still attached to the little rover thing that I made. I'm not sure that they're smart enough to know how tall lettuce is. I just plan on growing like butter lettuce and some what is it called? Not the really tall kale, but the kind of wider kale. So nothing very tall. Maybe some like parsley and rosemary, and that's probably it. Parsley and rosemary. So nothing like peppers or tomatoes or anything like that. But maybe I should this could be reconfigured, I suppose, to be taller, but yeah, mostly just like things like that size. So this would adjust the light height, and maybe this is over engineering as well. But I was thinking maybe some buttons that could move this up and down in a display that would show me how high the lights are. So, and that would be controlled via a servo motor or a stepper motor up here that could control this light height. And this might be the over engineering part. It might like not matter that much how close the lights are, but it could be another fun thing to build. So I'm seeing this as kind of two separate projects. One project, which is the fan, the heating, and the lights turning on and off, and then the stepper motor adjustment piece. So initial thoughts, Zenhaver.
Seems like a fun project. I was sort of trying to think to myself what the advantage would be of a self-adjusting or even just manually adjustable light height would be in a fully enclosed system. Light is gonna not diffuse out of it at all.
Mm-hmm.
So I would be interested if you learn any specific advantage to having the lights be closer or not fixed.
Sure. Yeah, I don't know, and the it's worth noting too, the inside material here would be reflective. So I'm gonna get some foam, some insulation foam that has a reflective inside, and all of the reflection would be pointed inwards. So, um,
Another thought related to the temperature, if you're having
yeah.
a fan constantly blowing in air
Mm-hmm.
that is of the temperature of your basement, would those low current heating pads be able to keep up with that constant rush of new cold air coming into the cabinet?
That is an excellent question. I would think as part of this design, the fan would only turn on. My mouse just decided to die, by the way, as I'm doing this. Here we go. Would only turn on if the temperature was too high. So if it got too hot in there, the fan would turn on. And
I
it could
see.
get too warm from the lights and the heating pads together. So it's kind of like a balance thing. And I could even see it doing an air exchange like once per day or something.
I see. I had assumed it was for ventilation purposes, just making sure that it's supplied with, I don't know, fresh air.
That might be something it needs. I'm not sure if it does. I think that's worth That's worth that. I think I'm going to ask the internet about this design after a little while here and write up after our talk today. But my initial thought was that it would just exchange and cool if it needed to be cooled. But
Very good.
Chef Rex said, that's a pretty good size. There's really no such thing as over-engineering. Ah, I like you. This is great. I'm designing a 5-axis CNC milling machine. That's awesome. I work as a manufacturing engineer for a tool and die company. I'm over-engineering that if it were possible. Okay, gotcha. I like that. Welcome. Thank you for joining us tonight. So maybe we look and see. I mean, a lot of people, when they do their hydroponic setups, they darn near stick the lights like right up next to the plant. You know, if you think about, there is probably some light absorption in the walls, unless I just put mirrors there, I guess. But there could be some lost, but maybe it's closed enough where it doesn't matter. That's one point that I'm kind of missing on this grow situation, is that these lights that I'm using are just shop lights. They're not specifically hydroponic grow lights, because those are expensive. They get really spendy. So this is a little bit of a hodgepodge kind of thing, but I think it should be bright enough. But I think the core things I need to account for are turning the lights on and off when needed, and making sure it doesn't get too cold or too hot in there. I think that's really the core of it. There's another addition that I might make. Have you ever used one of the non-filter type humidifiers in your house?
I don't think so, no.
So you can get these, they're called like ultrasonic humidifiers. Let's see if we can find one. So ultrasonic humidifiers are, go away cart. No, everybody doesn't need to, oh no, I did that wrong. Now people know what project I'm working on next. Go away. So ultrasonic humidifiers are, they have like this little machine in them. Goodness. They have this little machine in them that, I just can't use the internet today. I'm just going to go back. And they just like vibrate ultrasonically, and it turns the water into a mist. And I could use that for keeping the humidity up for the plants if I needed to. I've had some of those, like just for my house. I had one in my bedroom, and my wife and I had to get a different humidifier because we were both having dreams about people screaming at the top of their lungs, because we could probably just barely hear the ultrasonic little noise that had like a really high-pitched whine. We kept on having screaming nightmares from that humidifier. So I don't think the plants will mind as much, but I found you can get like just a controllable via little deal for like, I think it was like $10 or something like that. You just put it in some water and it turns some into mist. So I
That's
may
a
add that as well.
that's a 1-star Amazon review that I would think is a joke if you went on and rated it 1 star. It works
Yeah.
really well as a humidifier, but gave me screaming nightmares.
Yep.
1 out of 5.
Yep. Yep. Yeah, it could be that, or my house is haunted and it's spilling into your subconscious. It's definitely also possible. I think you're probably right. Yeah. Never know with these rental houses. So I might add that as well. So it's really, I was looking at this and it's like, well, it's like maybe 6 to 8 relays, probably, and then some controllers or some sensors to turn those relays on and off. Is kind of what I'm seeing this project as. Some kind of stepper motor controller for the lights raising up and down if we decide to do that. It'd be a relay for the 120 millimeter fan. It's a relay for the heated beds, and then relays for the lights. And I don't see really a need for having the lights not controlled all at once. I could have them have separate relays for each of them, but I don't really see a major need to, and they don't really have a lot of current drawn through them. So
There is a chance that you wouldn't need a relay for the fan, um,
Oh,
because fans, if you if you get a CPU fan, those are often controlled via PWM. You can control their speed
oh,
via PWM, and you could
cool.
always have power applied to it, but just turn it on or off via that signal.
Okay, that's cool.
That was just a random thought I had.
That's cool. And you could, yeah, you use that for your brewery stirrer, right? Your like
Yes, that's
stirring
right.
mechanism.
Yep.
Cool. Neat. So that's the project. Um, I don't know if you can, now that you've seen it, we'll maybe do some thinking about what parts could be 3D printed or designed. But that's the general thing. So I don't know if I could possibly do this all with one Arduino, or if it's going to take a couple of them. I have 3 Pro Micros and 2 just regular Arduino Unos.
So let's think about how many inputs and outputs total there would be, right?
Okay. Yep.
That usually controls how many Arduinos you need for a project. Just
Let's
off the
see.
cuff, it feels like you should only need one.
I wonder
Um,
what the best note-taking thing is for this crazy tool. Dimensions. I'll just write it here. Okay. So inputs and outputs. So inputs, what do we got? We have there's a sensor in my new kit that we're going to showcase in a little bit here. That is a humidity and temperature controller, right?
I'm not sure. If
Oh,
it's the same board, it's possible that that would be just one input, but for now, let's assume that it's two.
got it right here. We've got 3 pins on this bad boy. So this is the temperature humidity sensor that I have with my new kit that we're going to show in a little bit here. This is it doesn't tell me, but there's 3 pins on it. We don't know what those do, so we're probably going to have to go through a tutorial on setting this particular one up, but I think it's safe to assume that 1 is ground and then 1 is probably for temperature and 1's for humidity.
It's probably power, ground, and some sort of digital communication interface. I'm trying to remember what digital interfaces are one wire. But the data sheet would be able to tell us just fine.
Yeah, I'm just going to pull it up here for this. This is the DHT11. DHT11. Digital temperature humidity sensor. Okay, so that's probably just 1 digital pin then, right?
Yes.
Data pin.
Yep, it's got a data pin. Spits out a digital signal on the data pin.
Okay. Now, when you say inputs, is that the important piece? Is that it's a specific pin for it?
Yeah, because every input and output that you have will use a pin on the Arduino. And there are ways to get around that, but they're complicated, and it would be nice if you could just have a single pin, a single use for each pin.
Yeah. And then that's it, right?
Yeah, as far as
Um,
inputs go, you got your temperature and humidity, and yeah, I think
and
that seems like it's it.
if I was going to do the stepper motor for the moving the light, I think right now, let's just assume that we're not going to do that part of the project right now and just get the core functionality without the lights moving up and down. Because I really don't know enough about the stepper motor controller and how many pins that's going to take just to run that.
Yeah, stepper motors, I think are up. I can't remember. Nope, I haven't worked with stepper motors enough.
Right.
Let's ignore that.
Ignore that. We'll check that out later. That's a nice to have. We'll put it on the backlog. Sorry. Um, So then that's the only input. So then the outputs are, so lights, fan, and lights, fan, and heater pad.
And you said how many relays did you think each one of these would require?
So the lights are really low current. I bet we could run them all off of one relay because I don't really see the need to have them partially on or partially off.
Yeah, agreed.
So I'd say that's one relay. The fan could be PWM or one relay. And then heater pad would be one relay, I believe. So 3 relays and a temperature humidity sensor. Doesn't really seem that complicated that we have it written out.
No, I think one Arduino would be more than enough.
Excellent. That's a good start. Cool. Well, so now that we have this kind of scope figured out, one of the things that I picked up this last week, which I'm very excited about, is this thing. Oh, there we go. That was a nice dramatic focus in and out. So this is the most complete starter kit for Arduino Uno from Elegoo. So I got this for like 36 bucks. I'm really psyched about it. And it has a whole assortment of things. And so for the next part of this series for doing this learning electronics thing is I'm going to start off by going through all of the sensors and controllers that I might be needing for this project. So one of the first ones for that is this fun little temperature humidity sensor. Oh, cool. Chef Rex says stepper motors are +5 volts, ground, pulse, and direction. So 4 pins for that. So we could probably get that. We could probably account for that with this design even.
Oh, interesting. So you set the direction and then just pulse the pulse pin each step you want to advance the motor?
I think so. Stepper and a stepper driver. Yeah, I believe I have both of those in this kit. So, so the projects I'm going to be pursuing are this temperature humidity sensor. There's also a relay module here. So I'm going to be doing the relay build, going through that tutorial. This might be the first one that I do because I think this is probably the most useful, just knowing how to turn on and off relays. Just in general for all the things. So I'm gonna look at that. And then there is somewhere here. Here's the stepper motor. And there is a stepper motor driver somewhere in here. I have to find what it looks like. I don't know what it is specifically, but this is the stepper motor. So I don't.
There's a picture of it on the upper right of your guide.
Right. Found it. So this is the stepper motor driver. This stepper motor does not look big enough for the project that I have in mind. I would probably need a much beefier one, or maybe some gear reduction or something to lift up the lights. I don't think the lights weigh very much at all, but probably more than this small motor can handle. So this is the stepper motor driver, I believe. Yeah, yep, that's kind of what that illustration looks like. So that's another project I'd really like to do. Stepper motors are neat. Would love to learn how to do that. I'm intrigued about Chef Rex's CNC milling machine. That sounds cool. Thinking about stepper motors. So yeah, that's basically it for this project then. So that's the first phase of this, I think, is we're going to go through and hybrid steppers. So Chef Rex says at least the inputs is for those are the inputs for CNC steppers. using hybrid steppers for my 5-axis project. Ooh, what's a hybrid stepper? That sounds cool. That's a black bag go. So Zenhaver, what should we start with? What project should we begin with today?
I think that we should start with the temperature and humidity sensor.
I think you're right. That is the core of what we're trying to build. So I know we're going to need this, so I'm going to set this aside. I think the other thing that we're going to have to work on is just getting our new board configured, right? Getting the everything involved added, such as like the, I'll make sure we have the right, we got a new breadboard too. Sick. I'm like early enough in my projects where I only have one breadboard, so it's nice to have two. I have set up the our IDE for this new Arduino, and got some cables here. This is my cable. This is not very long, but I think I should be able to use it yet. Look at all these jumper cables. This is awesome. Look at them. And they're different lengths too. All right. Oh, this is going to be great. So, yeah. And if we have any extra pins, it'd be cool if we could do a display, but that display used a lot of pins, so I'm not confident we could do a display and all of those controlling things. So I don't know. We will see. Oh, Chef Rex says, a hybrid sensor is the group between a servo motor and a stepper motor. A stepper motor has no encoder, meaning that there is no feedback for the position. There's no way that the drive can know where the motor is position-wise in its rotation, or is able to count rotations. All movement is relative to the start position, meaning if you over-torque the motors, they jump a step and the controller is none the wiser. Okay, I gotcha. I think I was watching, I can't remember the name of the YouTuber, but he was using a treadmill motor, treadmill stepper motor to turn it into a servo motor for some ridiculous CNC machine thing that he was building. Yeah, I think he was talking about adding some of that awareness, the encoder, so that it knows where it's at. That's cool. Thank you for typing that out. I know that's a lot of typing, so appreciate it. All right, so this is going to open this up here. This is our fresh Arduino. You know, I wonder, now that I've just opened this, would it be smart just to like take the wheels off of this thing and just use this project board? I think that makes a lot of sense, doesn't it?
Yeah, I really don't see any reason why you wouldn't. Yeah, why you couldn't do that.
I think
you're already familiar with this particular red board, so
yeah, let's do that. That seems way better. I knew I shouldn't have stuck these dang wheels on here. Let's rip this thing apart. And there we go. Cool. Well, I'm just gonna put this back. All these fun things. It's just the kid at Christmas problem of like it's a new thing, so I wanted to take it out of the packaging. Terrible. Churlish. Oh well. So let's unhook some stuff. So I think I have a visit to Harbor Freight in my future here. I'm going to pick up some of the Harbor Freight parts bins. They have some really nice black and yellow parts bins, which I've used for other projects like my leatherworking stuff. So I'm going to be picking up those, I think, and that's going to be the new home for things from these kits. I'm going to move them from probably from the bins that they came in and into something that's a little more consistent. At some point here in the future, just because like this kit is nice. I mean, it's nice that it has a case, but it's pure chaos in here. There's no inter-organization or anything like that. So I will be transitioning all of these things into something that makes a little more sense, and then hopefully not just chucking this into the bin, but maybe finding some other use for it. But it's Not particularly useful without any internal organization, you know. Pry this chip out. No, I like it. No need to apologize about the. Let's see, is that a new block of text? It is. Cool. I didn't see that. Okay. So Chef Rex says AC servo motors have position encoders and are much more torquey but run on AC. Hybrid DC steppers have encoders on them that control. The controller can know where and how much has moved and how much current is required, and the controller can see it and give the motor more or less current depending on the use, meaning they run much cooler since normal steppers have a fixed current system. They always receive their max current, so they run a lot hotter. That's interesting. I didn't know that. So if a hybrid stepper jumps a step, the controller will fall into an alarm state. That's cool. I need to learn more about that. So I wonder, like, Zenhaver, do you know if the stepper motors in your 3D printer are AC or DC?
They must be DC because they're being driven off of a power supply.
Okay. That makes sense. Whereas an AC stepper motor might be something like a treadmill. Maybe? I don't know.
Could be. I actually don't think I was aware that AC steppers were a thing. So
Cool.
yeah, yep. I've had my 3D printer jump steps as well, especially with the extruder.
I saw online some crazy person was trying to, like, that's a nice thing to say. Some very ambitious person is trying to have their 3D printer extrude clay.
That sounds amazing.
I
If
know,
you could
right?
get that to work.
Super cool. I don't know how. That seems like a lot of pressure involved. And a very heavy thing, too. Like, moving that extruder around, if it has this big clay hopper on it, sounds like a nightmare.
Yeah, I wonder how you would apply force to the extruder in a controlled way with clay. Because so much of PLA and other 3D printers is the ability for them to retract from the extruder to control the extrusion when the print head needs to move across a distance or a gap.
Sure. Okay, so
So
it can pull back and stop.
subtractive manufacturing. I like that. I don't think I've actually heard subtractive manufacturing before. That's a good term.
Good. Let's get a couple more things to remove here. I'm actually going to put this ultrasonic sensor in with the other one that I have. Let's see if they're the same one. Yeah, they're the exact same one. Cool. So the two ultrasonic distance sensors are the same, which is really neat. So this one's from the SparkFun kit, and this one is the Elegoo one. So neat. Put those together. Cool. Subtractive manufacturing is cool too. I want to do some CNC stuff. I've been really enjoying the Zener, have you watched the Wintergarten YouTube series?
I don't think that I have.
He's the guy who made the marble music machine.
No, I don't think that I have tuned into that one.
Oh, yeah. Isn't it great, Chef Rex? Chef Rex is my favorite. I know. He's so cool. I've been trying to get through his entire series of Marble Machine X, and I just watched his building of a CNC machine in that shipping container, and I was like, maybe I need a $3,000 CNC machine. And I thought, no, you leave this page. Do not visit this page. because it's super cool. He's making some really cool gears and stuff. Yeah, no, I highly recommend that channel. He's super good. I'm actually going to start having his music on as my intro music for these because he opened them all up for use for streamers and stuff. So let's see. Oh, yep. I watched that episode as well. That's very good. Super cool. Really cool dude. Engineer, artist, man. So move this binder clip. Okay. Let's move on to. I want to show one just real quick. This is the. Eventually, I'm going to be figuring out how to get this room set up for doing streams because this is my actual craft studio. It's a lot messier than this SketchUp will show, but it is set up just like this. But this is again where I was saying I like to use these shelves a lot. So this is the workbench setup that I have in my studio upstairs. So it works quite well as a nice little workbench. Now I have some pegboard and stuff for that. So eventually we'll be up here for these streams, but not quite yet. Just because I still need to figure out how the hell to mount cameras to make this actually look okay. So someday. Anywho, well, I find the I need to find the guide for this because I forgot to set this up on this machine actually. So it'll just take me 1 minute to find this on my computer here. Oh, and I haven't connected to my fancy new network storage yet. Let's see if I remember how to do that. Zenhaver, do you have any other thoughts or stories or 3D printer things that you're musing about right now while I try and find this?
Let's think. My girlfriend, whom I live with, she recently went on a bit of a Christmas decorating spree, and as a part of that, bought some bins to store some various things in. At one point today, after she had done some work down here, I came down to find my 3D printer area completely cleaned up and everything shoved into a bin because she,
no,
because she was
no.
sick of it being strewn everywhere about.
Oh no.
It looks great now, and she did not actually touch or move the 3D printer itself, so none of the adjustments
Nice.
went awry. So
That's excellent. Way to go.
all it was just, yeah, I was sick of seeing everything, so I put it all into a bin, and everything turned out okay.
That is a good story. That's not how that story always goes.
No. Escaped unscathed this time.
Mm-hmm. I was concerned. I wish I remembered how to add. I'm gonna have to look this up later. We'll just have to find it from the Elegoo site. Chef Rex says, yeah, I stream pretty regularly. I was streaming till about 9 Eastern time. Stream in your machine shop. I build scale working coal-fired steam locomotives. They haul me and my fat rear end around the track, and I'm just enjoying New England IPA while watching this. Oh my god, steam power. That's wonderful. I'm going to follow you. That's great. Cool. And thank you for the compliment. I appreciate that. That's neat. Steam power is so cool. That's fascinating. Is this V1 or V2? Most? All of these things. Look at how these things are named. It's just driving me nuts, you guys. Super starter kit. Most complete starter kit. Maybe it's this one. 25. They just aren't, they don't seem very different. Most complete starter kit. I think it's this one. Arduino R3. Yep, there we go. Do I have V1 or V2? I'm gonna guess V2 based on the copyright date. So, sorry about the delay. Forgot to get this on this machine. All right. Gotta unzip the deals. Maybe I need some more bins. What keyboard am I rocking? Yeah, so this is, I should actually know the name of it. So this was the cheapest and smallest, that didn't get too ridiculously small keyboard I could find on Amazon. It is a E-YOOSO, E-USO, and then I went and got some fancy keycaps. So these are MX Blues. I think the whole kit and caboodle with the keyboard and the switches cost around $60. But I have to showcase, now that we're talking about this, why I got this particular one. And it takes me just a moment to get all the stuff out of the way here. But this is for a future project that we're going to do on this channel, probably months from now, once I learn more. And this is just so satisfying. So I have to show you. I can't help myself while this is unzipping. So this here is the case I'm going to use for this project. I'm going to be making one of those fun little cyber deck things where you have like a little computer built into a thing. And check this noise out. So I'm going to put the screen and all the bits in here, and then this is going to be the work surface here. So we're going to go to overhead mode and check this out. Oh, I have to move the cable. There's cable management in the way, but if I move that, look at this. It's perfect. There is maybe an 1/8 of an inch gap on the walls of this. This fits almost perfectly in this case. So this is going to be my cyber deck eventually. Isn't that wonderful? So this is definitely a 3D printing project in the future. Is for some different things to change the tolerances and stuff. So I know it is like it was made for this case. So I was so psyched when I found it. When I found it, I was really psyched and I bought it right away. And then I was like, wait a minute, I don't know any of the things that I need to know to do this. So that's what I'm trying to correct right now. But in the meantime, it is my video studio keyboard. So that's the story of that keyboard. Because you're an engineer, I thought you may enjoy that. So this is, let's see, this is having a weird error. Let's just skip things, and then it'll probably be fine. Yeah, it was almost like it was built for it. It's quite good how well that turned out. And yeah, so custom keycaps, and then I'm using these MX Blues for it. And that particular keyboard is hot swappable, which was one of my requirements, so that I could swap out the different switches easily if I wished to. So that's all extracted. All right, so let's go to English. Go to, this is the guide here. So let's go find the temperature and humidity sensor. No, Go away. Why did this open up in Edge? That's terrible. So this is called the DHT11 temperature and humidity sensor. So let's go find that. Here's the table of contents, what we all got in here. So we want to go to page 91. All right, there we go. Okay, zoom in a little bit. In this tutorial, we will learn how to use a DHT11 temperature and humidity sensor. It's accurate enough for most projects that need to keep track of humidity and temperature readings. Again, we'll be using a library specifically designed for these sensors that will make our code short and easy to write. So we have our Arduino Uno R3 and so 3x male to female DuPont wires. So I think that's these here in this ribbon. I almost don't want to remove this from this ribbon, but I probably should, huh?
You could just plug the sensor into the breadboard and run wires to it that way.
Ah, yes, you are correct. Okay. So the DHT11 digital temperature and humidity sensor is a composite sensor which contains calibrated digital signal output of the temperature and humidity. The dedicated digital modules, collection technology, and temperature and humidity sensing technology are applied to ensure that the product has high reliability and excellent long-term stability. That's kind of just saying all the important bits are baked in, right?
That's how I would interpret that, yep.
Okay. Oh, Chef Rex says, a few years ago, I created a working radio and nav radio setup for my flight simulator setup using an Arduino and a controller and a small screen. Neat. Where I could change my radios in the aircraft using external I/O. It was the greatest little sense of accomplishment ever. That sounds excellent. That's cool. Yeah, if I got more into racing and driving sims, I'm definitely there, feeling it. I like that. Sounds cool. So applications for this are HVAC, dehumidifier, testing, and inspection equipment. Yep, all those things. Don't have to read that. Okay. This is datasheet stuff, right? This means nothing to me. Does that mean anything to you, then, ever?
Which part specifically?
Hysteresis and long-term stability.
Hysteresis is a well-known term. Less than plus or minus 0.3% relative humidity. So I would just interpret that to mean that, like, let's say relative humidity was at 50% and then dropped down to 40%. It could move up to 43% perhaps, or 40.3% before it started increasing again.
Okay.
Hysteresis usually just means that there's like a lag between a changing value.
Okay.
That's how I would interpret that.
That seems fine.
Yeah, that's a pretty small percent. I wouldn't be too concerned about that.
No, not for my scenario. Okay.
Response time is one time constant in 10 seconds. Is that what I saw up there?
1E, 63%.
Yeah, so it will shift one time constant in 10 seconds. So it'll take 10 seconds for, like, if there was a step change from, like, 50% humidity to 70% humidity, it would
Sure.
move 63% of the way from 50% to 70% in 10 seconds. And then it would probably take another 10 seconds to move another 63% beyond that. So it's kind of giving you the how quickly it can respond to step changes.
Okay. What does the E stand for there?
Uh, E from mathematics, like natural. What is it? The natural. I can't remember what you call that term in mathematics, but it is literally the letter E.
E. The E stands for E. Gotcha. I really should have done more mathematics. I did not do any, really. I somehow avoided doing anything more advanced than basic algebra and graduated college. Art student. Okay, so it works on 3.5 or 5 to 5.5. Okay, data serial pin. Wouldn't delta be more applicable? Couldn't tell you, Chef Rex. Our resident mathematician isn't in attendance tonight. Usually there's one that may join us, so where's V.E. Kruger when we need him? Okay, so the center pin is a VCC, and VCC stands for, and this is something we talked about last time, that's the like digital controller voltage, right?
Yep.
Okay.
Technically stands for voltage common collector, but that is a transistor specific term that you should just interpret to mean whatever power you're powering the other digital controls at.
Why is it important to have them at the same voltage?
Let's see. So if you had the Arduino at 5 volts and ground and the sensor at 3.3 volts and ground, when the sensor decided to go logic high, for example, it would bring that pin to 3.3 volts. But the Arduino, since it's at 5 volts, may not interpret that 3.3 volts as being logic high. It may
See it as
interpret that
logic
as
low.
being logic low or undefined or something like that.
Okay.
So you
and
need
we
the
don't like
voltages.
undefineds.
Yes, you want those voltages to be equal so that the digital logic all makes sure that it interprets highs and lows correctly between components.
Excellent. Thank you. So I'm going to hook this up how they have it here. So I'm going to use red for the VCC, blue for the digital pin, and black for ground. So I'm going to set this up to the rails just to do it proper like. Although that does complicate it a little bit. Ooh, okay, so there we go, okay. So that, how does that look? I'm just trying to compare where this might actually be. So this would be really easy for me to confuse which side is which. So I'm going to put it like this, because then that makes more sense with the drawing. So I'm just get out of your keyboard. So setting this up like this, like so, and that sits in similar to how it is in the picture. So the, oh, actually that's the opposite. So this is just flipped around from this image. So it's actually then more like this here. Voltage common collector. So this is the same kind of setup as they have in this illustration. So I'll use this even though it is upside down for me. From how I usually use this. And that's in column A, starting at row 1. So ground is going to be at the bottom. Nope. Ground is at the top. Okay. 5 volts. There's shoe polish on my hands from my last project I did here. Oh no, I got black shoe polish on my chair. That's awful. Don't do that, kids. Not good. Time for some food, BRB. All right, see you in a bit, man. Man, person. Or madam, I did not ask. So get these wired appropriately. It's all seeming up to snuff here, Zenhaver, so far?
I can't really see anything in the current
Okay.
view. Okay, now
Sure.
I'm lagging a little bit behind you since I have to have your stream open on Twitch since the Hangouts feed dropped.
Did it? Okay. Shoot. Um,
Yeah.
so
So you got, yep, data, power, and ground. Okay. Looking pretty kosher to me.
going to pin 2. It's not a PWM pin, but that's okay. And yeah, cool. There's the wiring diagram. Okay, so for code. Oh, that's nice. Yeah, that's kind of what it looks like for me. So after wiring, please open the program in the code folder lesson 12, DHT11. So let's try that. Go to code. Lesson 12. Nope, nope, not what I wanted to do. Yeah, I think it was a good call just using the Arduino that we already had set up for this. All right, so I'm going to plug in the Arduino now. And I'm going to upload. Oh. DHT non-blocking H, no such file or directory.
Yeah, it is likely trying to use a library from the libraries folder of the directory that you had launched this from. It's likely that the Arduino IDE can't find what you mean by that header file. And I'm not quite sure how to resolve this.
Probably starting at the beginning of the manual.
Possibly.
Let's try and find, there should be the first one, should be like setting up the libraries.
If you maybe just navigate on your PC to where the Arduino IDE is installed and copy and paste the libraries folder from into that folder. Oh, looks like page 23 is exactly where we need to go.
Probably just going to tell us to do the same thing. Oh, so manage libraries. Using the library manager. Okay. Install a new library, library manager. Open the ID and click to the sketch menu and then include library, manage libraries. Let's open that up. So sketch, include library, manage libraries. And then I need to find version 1.05. What is this? So would I do this for each library then that it's asking for?
I am not sure. I have never done this before in
Oh.
my Arduino IDE.
Let's try it. I'm going to try it just briefly and then we'll go the copy and paste route. So this library is called DHT non-blocking. Search. Nope, didn't work. DHT sensor library. Arduino library for the DHT11, DH22, etc. That seems right.
Sounds right to me.
How would I know which version to get?
I'm sure it's fine.
It's
Just get the
fine.
latest.
Yeah.
They're usually pretty careful about like backwards compatibility and stuff like that. So
Like that. It's fine. Some thirsts. All right, so let's try this again. Close. Upload button. Nope. No such file or directory.
Was there something in there about needing to like restart or anything like that?
Oh. No, it just says you can close the library manager. Oh, it's now available in the include library menu now. So I still have to go up to include library and then find it. So that would be DHT sensor library. Okay. Oh, I see. Okay, so now all I did was just like add this library at the top, I think. Seems sketchy to me. Sketchy, get it?
Blah.
Um, and it didn't work. Okay. So I think the next step is let's just put it in place from the zip file. Importing a zip library. So
Oh, do you have a zip file available to install from?
um, yeah, I have this zip file here, which I believe is a library.
Try, yeah, try installing it as a zip file from the Arduino IDE.
Zip library. There. Uh, English. Ah, DHT non-blocking. Okay. Oh, it's already got it, so I shouldn't need to call it twice. Okay, now let's try it. No errors yet. Hey, okay. Sick.
We did it.
We did it. We did a thing. All right. Bring this back. Okay, so let's see what this does. So initializes that. Starts up serial. Static Boolean measure environment with floats of temperature and floats of humidity. The asterisk means that is
Being
that's special, right? We just
it
learned about
is.
this. What's that called? It's for strings.
Not quite.
Can be used for longer strings though. It is
Yes,
a it's like a bookmark.
a good analogy.
Um what is that called? I give up. What is it called
It's
again?
a pointer.
A pointer. Thank you. So that's a pointer variable, right?
So it's the as parameters to this function, it passes a pointer to a float and a pointer to a float.
Okay, and floats can take up more space than we would want to take up, or than we can take up with a simple integer.
Yeah, floats are usually four bytes.
4 bytes. Okay.
They can represent decimal values.
Do floats take up 4 bytes even if it is not filled out?
Yes, floats will always consume 4 bytes regardless of the value contained inside of them.
Oh, that's interesting. I'm sure that
Floats.
that actually comes into play quite a bit with your work, doesn't it?
Yeah, a bit. Floats are the data format for a float is that you have some number of bits that are assigned as what's called the mantissa. Then you have some other number of bits assigned that are called the exponent, and then you have a single bit that's the sign. And using
Hmm.
a mantissa, which is sort of like a base number, and raising it to some exponent, you can represent essentially, a huge range of floating point values between, you know, a negative billion and a billion, some huge number of values in there.
Dear
based on
God,
that format.
that's wild.
Yes, it's a
Really?
very yes.
That's nuts.
Because like the bigger the number is, the fewer like decimal points you get, or like digits after the decimal, I should say. So if
Yeah.
you're trying to represent a number that's like a million, you only get like a couple digits after the decimal. But if you wanted to represent something like 0.123456789, you could also do that.
Hmm.
Basically, the precision of the number changes based on how big or small the value is. So it's a very clever data format.
Oh, that's cool. I just love with this stuff how clever. I mean, it's all just hacks, right? Like it's all just like I bet if we did this, we could squeeze a little more horsepower out of it.
Yeah, floating points. I think there's been quite a bit of thought put into floating point numbers. It's a very efficient data format.
Oh,
It
cool.
does have its trade-offs, obviously. The classic one is like if you add two floats together, point 0.1 and point 0.2, it doesn't actually equal point 0.3 because you can't represent the numbers point 0.1 and point 0.2 perfectly using that data format. So
Oh
computers have
no,
a hard time counting sometimes if you use floats, but they're very useful.
that's hilarious. Is that just like a that must just be like a huge problem to solve?
It has been in the past for sure. Computers these days are usually pretty there's some good stuff going on under the hood, especially like on desktop PCs that handle a lot of those weird byproducts of the data format just fine.
Neat. It's so funny, like how I mean, I know it's not basic, but how seemingly basic some of the problems are that are solved by some of these clever little tricks that we've found just with the pointers and with the floats and stuff like that. It's wild to me how these little small things are so foundational to all of computing that it's so easy to take for granted all the rest of the computing that we do every day.
Yes, that's a good point.
Neat. So we have our pointers. Oops, let's not do that. Um, aim to these. And are these? I'm forgetting the terminology. So this is a function, right? This is a variable name for the function, and these are
Again,
the
I'm
values.
lagging behind you a little bit, so what you're
Oh,
doing on screen is not corresponding to what I'm hearing.
sure.
But
I'm gonna refresh that Google Meet window and just see if that helps on that end. Oh, it's like completely stopped. Oh, I see what happened. It looks like it is just trying to use it's trying to just use the USB microscope. That's why I couldn't access the USB microscope in OBS is because Google Meet was trying to use it.
oh,
So
I see.
so
Excellent.
so that should be resolved. Let's see if I can use the microscope now. Nope, not yet. That's okay. Um, so are you in the present now, my
We're good
friend?
now. Yes.
Okay. So function. This is a function.
Yes.
This is the function variable name.
The function is named measure environment.
Okay. And then these are the values within the function.
Those are the parameters being passed to the function.
Parameters
Yes.
being passed to the function. Okay.
Or parameters being used by the function.
I should probably just make a little guide that points that stuff out. I love these definitions. Like all the terminology stuff is so darn important just for being able to Google your way out of a hole. That
Yes, that's true.
it's yeah.
And
I
then
go very in depth on those when I do any of the coding classes that I teach.
that is a good call. So measure environment returns a Boolean value, a static Boolean.
Okay.
And a Boolean it can only ever take two values, true or false.
Yep. So this is like yes or no measure environment. This is kind of just turning it on. That's
We would have to, oh, it looks like in the comment it says it will return true if a measurement is available.
okay. A little baked in failsafe.
Yeah, so you can tell if you're getting stale data or fresh data, probably.
Yeah. So static unsigned long.
So this is an unsigned integer type, except that it has more storage associated with it, so we call it a long.
Versus a short, or what is this?
Short, int, and long are all different integer types.
That's right.
This
Yep.
one is a 4-byte value.
Okay.
Unsigned means that it can go from 0 to 2 to the 32.
Okay. Milliseconds.
And millis, that it gets the internal counter timer from the Arduino.
So that's probably the 10-second thing that we were reading about.
No, millis would just return the number of milliseconds that have elapsed since the
Oh, okay.
Arduino was powered.
So measure once every 4 seconds. If millis minus measurement timestamp is greater than 3000, what does that stand for?
Unsigned long. So that's basically a way to, in shorthand, denote to the compiler that you want that number, 3000, to be treated as an unsigned long.
Should we be adding some comments to this, you think? This is kind of low comment on here, but
Possibly.
I guess we don't need to. I'll just keep trying to understand it.
Okay.
So is this saying if it's greater than 3000 millis?
Yes. So I don't quite know why it says every 4 seconds, but uses three seconds as the thing to compare against. But so this looks like it would do it every 3 seconds to me, but that's fine.
Yep.
Not super important.
We'll time it later. If digital humidity temperature sensor dot measure that equals true.
So it looks like it's calling some built-in function of the DHT sensor library.
Yep. Measurement timestamp equals millis. So it's an embedded if statement here. So this is saying, okay, so if every 4 seconds every 4 seconds do this thing, and this is this one inside of here. So it's just basically saying return true or false. If the sensor is actually running and you hit every 3 seconds, then return true.
Yeah, I would guess that built-in function .measure still returns like true or false based on whether the measurement is available or not. I'm not 100% sure. We'd have to go look at the actual function itself, but we can basically assume that DHT sensor.measure is going to return, it's going to fill in essentially values for temperature and humidity.
Mm-hmm. So that's just this setup here.
Yeah.
I'm so used to seeing like all of those SparkFun tutorials were so consistent with how they were set up. Oh, here's the setup.
Mm-hmm.
Too much space there. Okay, so there's the main program loop. So just declaring these variables as floats.
Mm-hmm.
Haven't they already been declared as floats up in the setup?
No. And those ones, those are in different scope. Or you're allowed to use the same variable names between those two functions because the scope of those variables is only applicable to the function that they're used in.
Sure. Okay. Do you consider that good practice or bad practice to reuse them?
I would consider it neither.
Okay.
It's based on context in my mind.
Sure. So there's the floats. Measure temperature and humidity. If the functions returns true, the measurement is available. So if measure environment, what do these ampersands mean?
Yeah, let's dive into that a little bit because this is a little bit tricky, but I will do my best to kind of explain what's going on here. So you
Yeah.
remember measure environment expected 2 pointers to floats, right? Expected a
Yes.
pointer to a float for temperature and a pointer to a float for humidity.
Yep.
In loop, we've declared 2 variables, temperature and humidity. When we declare them, the program will assign storage for those
Okay.
and put them somewhere into memory. The ampersand before the variable name indicates that you would like to take the address of that variable and use the address um, as the thing that you're passing. So what this is saying in sort of plain English is that when you call measurement environment, you want to take the address of the float named temperature and the address of the float named humidity and pass those as parameters to measure environment. And it works because measure environment is expecting 2 pointers to
Pointers.
floats.
Yeah.
So you're
Okay.
taking the address of temperature and passing it to measure environment, which is the address of something is a pointer to that thing.
Sure. Okay. So it's kind of like the other half of a pointer.
Yes, like if you tried to just pass temperature without
Yeah.
that ampersand, I expect that the IDE would throw an error because something you're trying to pass the value of something when the function is expecting a pointer and not a value.
Sure. Yeah. So we're not giving it an address, we're giving it the thing.
So if you remove the ampersands, you would basically be saying, I want to pass the value of the variable temperature and the value of the variable humidity to measure environment.
Okay.
But what measure environment actually wants is 2 pointers to floats. Makes sense?
It does. Yep. Um, so this is just saying, this is just a simple if statement surrounding it, that if measure environment is true, then this stuff happens.
That stuff will happen always.
Okay.
The function call measurement environment will always happen,
Mm-hmm.
and it just checks the return value after measure environment is done and returns the boolean. That's what's being
Sure.
used in that comparison.
So that's this boolean up here.
Yes.
Okay. This is really it's kind of fun seeing how closely that is connected with this.
Yep.
You can kind of like welcome back, Chef Rex. You can kind of it just helps to understand that they're connected like that. I think the last time we were working with pointers, it was a little more opaque to me.
hmm
So then it just says serial print t equals. So when it's calling temperature here, what is the impact of us previously only dealing with the pointers? Like, how does this
Hmm.
work to call temperature without calling like ampersand temperature?
Yeah, so when you're not working with pointers or trying to take the address of something, this is working just like a regular variable, right? You're
Mm-hmm.
you're you're saying you want to print the value of temperature, whatever it might be.
Sure.
So that's like the normal case of how you would use a variable is just have the name there. The program will interpret it as I want the value of whatever data is stored there.
Sure.
But once you start using ampersands and pointers that you start thinking about, well, I don't actually want the value of what that variable holds. I just want the address in memory where that variable is. And from there, I can do what I want to do with it.
Okay. I'm just surprised I don't have to like have it look for the location and then do something else.
Yeah.
But interesting. Okay. So then this is just a simple serial print. So if we go up to the serial monitor, we should see some stuff. Oh, we don't. Dang it.
Did it get uploaded and is it running currently?
It's powered on. And the correct pins. Oh, that's looking right. No
Uh,
smoke coming out of it.
as just a quick experiment, will you just copy serial.println, like the percent, the bottom one there, and just
Mm-hmm.
paste it outside of that if statement?
Side of this one.
Yeah. This will tell us like whether the program is working or if it's just always skipping over that if statement.
Sure.
Like if that if statement always came back as
Oh.
false. Okay, so that looks great. So undo
Zzz.
that. But I did also see some text up above that seemed to indicate like it was working.
Yeah.
So
Must have just needed to restart it
yeah.
or wait 10 seconds or something.
Yeah, maybe give it a few seconds here.
There we go.
Yeah, okay, cool. Degrees Celsius. Blah. What is
So
this?
I actually
Europe?
have a temperature and humidity sensor handy here at my desk. So let me figure out how to switch it to Celsius. So I'm gonna hold this next here and just see. This isn't really saying how accurate this is. It's probably because this AccuRite is yeah, Canadian. AccuRite is maybe not the most expensive controller. Yeah, I know. I'm actually super jealous of the metric system. I wish that we used it. When playing The Long Dark, I for sure am using the metric system for how much water my character is drinking.
Same. Mostly because
Same.
all of the values in that game are based on whole numbers of metric numbers. So when you convert it to imperial, you get like really weird values like this thing weighs 3.2 pounds instead of
Yeah.
like the 1 kilogram or whatever round number that the game is using internally.
What a good game. So this is great. Showing 16 degrees and 43% humidity, which I think isn't that far off. This thermometer was on the floor a minute ago, and probably if we took it apart, maybe it has the same sensor in it, or something similar, I guess. So I'm gonna deem that a success. Anything we want to play with on here? Code for me is way beyond me. Only code I know and can read is G code. Hey, that's impressive. I don't know how hard G code is actually to read.
I don't think I've actually ever opened a G code file before. I've
I
always
can
just
I can hear you clicking,
Yep,
so I'm guessing you're opening a G code file right now.
trying to. Notepad. Oh yeah, this looks kind of like an INI file almost. It's just a whole slew of values to instruct the printhead where to move and what temperature and stuff to use. Neat.
Nice, neat. So I think this was a huge success. Not too complicated. Uses it seems like there's a lot going on of like there's a lot of just if statements to make sure that's plugged in. Like
Yeah, I would say that
hardware
that's
is
accurate. It's
plugged in
trying to
correctly.
it's trying to keep a it's doing it's doing the state machine to make sure that a measurement doesn't constantly happen and that it only happens like once every 3 or 4 seconds.
Sure.
Seems like it's trying really hard to do that. It is interesting because the let's see, like the instruction manual or the data sheet indicated timing needed to be careful with
Yeah.
this sensor. So this is probably trying to adhere to that more closely.
It says
With
every 10 seconds is when it will update, right? With the 63% change.
that is just telling you like the internal characteristics of the sensor and like how long it takes to react to changes in temperature and humidity. That doesn't have anything to do with like the digital protocol itself. Interesting. Are you pinching it with your finger or something?
Yeah, I
Neat.
was. Um, so I'm also seeing that we're not really getting much for decimal points here. You know, we're accessing floats, but everything's 0.0. Is there some rounding happening?
I'm
Uh,
going to guess that that second parameter in serial.print is telling it like how many, yeah, like how many digits after the decimal or something to print it to. I'm not
let's see,
100% sure.
90, I think. Let's see if it tells us. Well, this is not the application that they had us install. uh, so I'm seeing a stark difference, like the 60 odd dollar difference between the between this starter kit and the SparkFun starter kit is that this is definitely not the code that we were working with here. But that's okay because we got it to work.
Yeah, it's interesting how radically different the two serial monitor outputs seem to be.
That's a good point, Chef Rex, is that the accuracy is plus or minus 0.3, then why even worry about that extra decimal? If it's plus or minus 0.03. I'm just more surprised that then why are we using floats that use up so much more space? You know?
Yeah, I mean, in this sort of program, storage space is almost completely irrelevant, right? There's like thousands of bytes of RAM and hundreds of thousands of bytes of flash storage on an
Yeah,
Arduino. So whether you use 2 bytes versus 4 bytes is inconsequential.
sure.
And using a floating point value is just sort of intrinsically more correct for this type of thing. A temperature you almost
Sure.
always think of as being a
Uh,
decimal value rather than a
sure.
whole number.
That makes sense. Um, well, so it's 9:41. I kind of want to keep going until 10. What I'm thinking is that maybe we try to turn on and off an LED. Hey, V. Kruger joined us, the resident mathematician. Good to see you, V. Kruger. So floats versus int matters in database engineering and where that size difference is meaningful. But for small scale projects, IMO, go with your gut. Gotcha.
I did just look it up real quick, that serial.print, where it's passing a 1 as a second parameter. That is telling it the number of um, digits after the decimal place you want to print.
It's just not even getting that much information, though, right?
Right. No, yeah, it's not. It's still always giving you 0.0. So the rounding is not happening from the serial.print. The rounding is happening somewhere else in the system.
V.E. Kruger, Chef Rex, if you're interested in math chats, V.E. Kruger does stream quite often. And one of the rewards, I don't know what to call it, but he does a math chat where he explains complex mathematical questions and different things like that on the regular. You should check him out. He's got yeah, it's good stuff. Real good. So, Zenhaver, what do you think we should make this temperature sensor do today? Should we have it just do an LED, like a warm, red or blue, faces about above or below a certain temperature? Should we
Could do that. We could make an LED blink every time it acquires a new measurement and spit something out to the serial port.
Oh, that's good. Sounds good. So, I don't know where we can write that out. Yeah. So what else would be useful for our application, you think? Oh, maybe what about just getting it to display out to an LED display or something too?
You mean like one of the 16 by 2 character display, or
Yeah, it seems like overkill. I do have one of these. One of these deals. This seems like a whole separate project though. Less to do with the temperature meter.
yeah, that would be an undertaking to decode how to drive one of those things.
Yeah. Let's just stick to some blinkies. things happening. So, so every time it writes to serial, I'll blink, and then maybe like a green LED for optimal temperature and optimal humidity, and then a red LED for non-optimal, or something like that.
Could be, yeah.
That could be fun because that could be a starter to the code we would use for the relay.
Sure.
Okay, so I'm going to unplug this, and I'm going to grab, because they're a little more at hand, I'm going to grab some of the LEDs from the SparkFun kit. I'm going to unceremoniously dump them onto this table. So I want to do so green and green. Let's do green and red. This will be for our temperature. Is this the right place to start for this idea, or should we do the code first?
I would wire it up first and then write the code. That's usually the order that I prefer.
Is there a preference with this breadboard with ground? Should I have like ground on the higher number on the bread, or lower down on the breadboard, or anything like that?
That is completely arbitrary, I would say. Whatever you would like.
I'm gonna do that's for the whether or not it's at the optimal temperature. I'm actually gonna do a little bit different. Let's see if I have enough pins for this. This is where I get too ambitious. Oh. There's a whole lot of stuff happening in chat. That's entertaining. That's an NG. Engineer.
Yeah, that's interesting, Chef Rex, where you write the program first and then set up the part. I find it a lot easier to like make the circuit, make sure that I have things wired up correctly, and then see what pins I've wired things up to when I go to actually write the program. It could be done. It certainly could be done either way.
This almost seems like doing the let's see. This seems like one of my main concerns with doing this is, and the limitation for how fancy I can get is really the number of pins I have. So I think this would be the first place to be like, oh, I guess I don't have enough pins, right?
Yeah, I would say so.
So 1, 2, 3. Oh, we need 360 ohm resistors. Resistors go on the positive side, right?
It doesn't matter. It can go on either side.
Really?
Yep, because you're just making a loop, and the resistor, it doesn't care whether it's on the positive side or the negative side. It will limit the current on either side just fine.
Let me get out my Knipex here and bend some wires. All right, so we have 4 already. We need 1, 2, 3, 4, 5, 6, 7. All bent up. You already said your whole job is subtractive manufacturing, so you're not doing the addition, you're doing the subtracting. Do one extra there. Exactly. Just gonna bend some of these. Do breadboard times. Oh, look at that nice bend. I find this part to be so satisfying, bending these.
Did you say those were 330 ohm resistors?
Yes.
Fantastic.
I might have said out loud 360, but what I meant was 330.
I would be surprised if you actually had some 360 ohm resistors based on what came in these kits.
Mm-hmm. It's a very niche resistor.
Actually, not so much. I would expect 360 ohm resistors to be readily available. I think I have some in the kit, the resistor kit I have. Typically, they kind of like the smaller the resistor value, the more sort of like increments there are. Like I would expect to be able to find, like 10 ohm, 20 ohm, 30 ohm resistors, but I would
Yeah.
not expect to be able to find 1000, 1010, 1020 ohm resistors, if you know what I mean. They kind
Sure.
of go up in increasing, logarithmic increments.
We're ditching the hat, everybody. We're going to unfocus the camera too much if I have the hat on. I think I'm going to, outside of the stream, going to fastidiously bend all of these resistors to be the same, like breadboard distance apart. They're a little inconsistent right now. It drives me bonkers. Oh,
Instead of hat, we're getting a good view of your hair instead.
are we? Oh, good.
Yes.
Look at that. Look at those curls. Probably a lot of gray in there, too. Getting there.
Chef Rex, that's a good approach to LEDs, I think. Only the worthy LEDs survive. Current limiting is for suckers.
Like natural selection, but for LEDs. I selected this one, naturally. I'm putting all of the resistors on the ground, just to keep things consistent. I haven't found a good one yet. That's funny. Okay. I got so many more black wires now. This is great. Oh, they're zip tied. Who would zip tie anything? I'd probably use more zip ties than anyone else that I know. I don't know why. Sorry for the gratuitous belly shot. I just had to refocus the camera. I really like zip ties. I use them way too much. You use zip ties much as ever?
I use quite a lot of them for cable management, but outside of that, not very much.
Oh, it's great for automotive repair. Um, a lot of the furniture building, all that kind of stuff. It's great. I'm not finding that many black wires in here. Chester, I'm sorry. Yeah, I know. I switched the camera to that view, and I shouldn't have before I got up. I should have switched to the one that didn't show that camera. I'm sorry. Picking out some different wires. Indispensable in plumbing. So we got some of these are shorter too. I'm feeling Zenhaver like having shorter jumper cables might be in my near future, where it seems like a really nice thing to have. I might get a pack. Okay. The Kruger says that zip ties are indispensable when doing plumbing. No, I forgot to add one of my resistors to the blue LED. It's here. This is fun. Fun. I'm enjoying this. I really do like this kind of work. I'm really glad that I kind of bit the bullet and just started learning it. There's a good while there, the past couple of weeks, where this is pretty much all I could think about. I think for the next Sunday, we are going to be making a servo motor that makes it so I don't have to stand up and press this dang button every 10 minutes when I'm doing this crap. Gosh darn it. Driving me nuts. And then I just have to lean in order to see. Stupid camera. Doing it stupid out of focus. Okay. All them ground wires are hooked up. So I'm gonna get 2 yellows, 2 greens. Well, it is late and I must sleep, says Chef Rex. Well, thank you so much for joining us tonight, Chef Rex. It's been a pleasure. And hopefully see you next Sunday. Same time, same place. For the next leg of the project. And I'll enjoy seeing your Steam stream. That sounds great. Excited about it. So when I'm choosing digital pins for this Zenhaver, oh cool, you're streaming most of the week. Awesome, thank you for joining tonight. Should I be picky and choosy about which pins for these LEDs, or it's just any digital pin because I'm just sending a low or high?
I don't think it matters which digital pins you pick for these.
Okay. Because nothing's PWM, so don't have to worry about that. So wiring up yellows. This has actually taken quite a bit longer than I expected to wire up.
It always does. It always takes longer than you want.
Are you okay going a little bit over 10? Actually, I think the writing process for this is going to take longer than just 20 minutes.
Yeah, it's possible.
I think it might be smart just to maybe we'll write some comments in tonight, just as to where things might go.
Sure.
And then we'll take a few minutes to kind of re-familiarize ourselves next week. And then we can do the writing. Or maybe I'll just do it in the meantime. I'll do that. Okay, there we have it. Here is our setup. So here we have our temperature humidity sensor. Oh, we don't have a ground hooked up to, oh yeah, we do. Temperature humidity sensor, this has not changed at all. And we have a blue LED that we're going to use. That's connected to pin 13 for whenever there's a refresh in the serial. Will be our heart. Would you consider that a heart rate monitor? Or a
a heartbeat?
Heartbeat, yeah. This way, so you see. So then we have a too cold We'll just call it, or maybe this is too high. Too high, just right. Too low, too high, just right. Too low for temperature and humidity. All with the proper resistors and grounded to our rail. That look about right?
Looks right to me.
Cool. Shove these LEDs back in their home. I should have chosen different colors for them based on too hot and too cold. That would have been smart. Yellow for the heartbeat. And should I just do that now because it's going to bother me? No.
Whatever floats your boat.
We're just going to leave it. We're going to leave it. That'll be fine. Look at this whole mess of jumper cables I have here. How do you organize your jumper cables?
I have not had to organize jumper cables for a long time. I think I have them just sitting in a box somewhere.
Okay.
Or maybe in a big Ziploc bag.
Gotcha. Okay, so back to here. So let's first things first is to declare pins, right?
Yes, I would declare a pile of pins that are associated with what you have plugged in.
So
and
would those
name them appropriately.
So if it's high or low, what kind of pin would that be? Would it be just an int? Or how would
you could set them up as ints. I think the functions that set up pins expect ints.
This a little bit out of my way. Get my keyboard up and running here. Okay. So, and how do you do comments? Oh, it's a pound sign, right?
No, double slash is correct.
It's not marking it as a.
I mean, there are double slash comments already in this file, so that looks like it's a comment to me. Okay. Looks like it's colored correctly.
Hard for me to tell. So this is the temp input. Are these static or no?
No, I would just declare these maybe as const ints.
Const int. And then I'm just naming these what I want, right?
Yes, it's your heart's desire.
Heartbeat goes 13.
I would probably append underscore pin to the names, though, to indicate that it's the pin assigned to that function or to that idea.
Should I do all caps or?
Purely whatever style you want.
How annoying is my keyboard?
Not annoying to me.
Excellent. 12. Correct. What would be like the in range?
I would use good, probably.
Oh, I forgot a semicolon. Were you going to tell me?
I was not watching. I was focused on something else. I figured I would come in at the end and correct all of your errors.
Fair. Good. Oh. Oh, that's from the other thing. Okay. I'm going to move this pin for the... So that's in the right order at least. Okay, so this is all the pins that we're dealing with today. So I moved the pin for the digital humidity and temperature sensor down to the bottom so that it reads highest number pin to lowest number pin. But this all looks about right, correct?
Looks good to me.
Cool. So when we write this, it's going to be, we don't really have to initiate anything in setup, do we?
We will need to set each of those pins to be digital outputs.
Oh, I'm going to
Pin
open
pin
up.
mode, I think, is the function name. I would leverage an existing sketch to find the right syntax.
Up to blink. Okay, yep. So we have 7 LEDs. 3, 4, 5, 6, 7. This one is for, that is actually pin 13. And then
I would use the variable names here.
instead of the pins,
Yes, that's the whole reason that we set
we set those
variables
up.
to be equal to pins. I think you should be able to just double click the variable and it should select the whole thing.
Oh, you're right. Nice. Way faster. If I can choose the correct Control C or Control V.
Very important.
Okay. What else does our blink command tell us? So this is digital right, high or low. So we need an if-else statement that the final else is, or an else if, sorry, right? So the final else is that all 3 of the LEDs are set to low. Maybe, or I wonder how we should do that.
Let's see. Could you describe what we're trying to accomplish again?
Sure. So what I'm hoping to do is when we are in the right temperature range, so we want to blink this first off on the heartbeat. But then for these LEDs, we want to have, if it's too hot, we'll turn this one on. If it's just right, we'll turn green. If it's too low, we'll turn on this one.
Mm-hmm.
And the same for humidity over here.
Sure. Okay,
So,
let's do the heartbeat one first then.
okay.
So I think the way we'd accomplish that is, well, let's try that again. How would you accomplish that, Grant?
I would do I would look at another time-based statement like this one here. Yeah, probably this one here, and I would trigger this, trigger the I would trigger low on this here, next to this return false, and I would trigger the high on in this spot here, I believe. So
Okay.
I'd be wanting to leverage leverage the existing logic that is printing anything to serial in the first place,
Mm-hmm.
which actually maybe is down here. Yeah, that's probably in here. I would just add low to this part, probably a high low to this.
Yes, I think that is exactly what I would do. You would probably want to avoid putting anything into measure environment function because it would kind of pollute the intent of that function.
Yeah.
This function's purpose is purely just to get a measurement and return two values associated with them.
Mm-hmm.
So the logic for blinking an LED would probably go in the main program loop.
Yeah. And I would even just say for this heartbeat, we'd probably do like we could do like a half second or something like that. Oops.
Half second is kind of long for a heartbeat. That's like 1/6 of the total time between
That's true.
updates.
Oh, I guess we have milliseconds, so we can do it quite a bit shorter. So
Yeah, 100 milliseconds sounds good to me.
so we could just put this here. Does this work like this? Would that function? Seems like a number of things happening.
Yes, this should work just fine, I believe.
So, but I need to change the pin. Should we try that?
Looks good to me.
All right, I'm plugging her in. Right, and upload. It worked. That's good. Let's see if our LED does anything. It isn't. Let's look at our serial monitor. And clear the output. We are
Should
getting.
we perhaps look at the wiring more closely?
Yeah. N13. Right? Set this up as.
Would you full screen the wiring?
Yeah. So here's the heartbeat one. It's a little less out of focus there. So that is all in row 8. Make sure all of it.
And you sure you have the polarity of the LED correct?
Oh, I am not sure that I have the polarity of the LED correct. I forgot about LED polarity. So I'm going to unplug it. Do you think I fried the LEDs?
No. Diodes, I think you would need to apply quite a high voltage to an LED to burn it out by reverse volting it. Diodes, by their nature, are meant to resist flow from the opposing current or from the opposing direction. So
I'm not really feeling much of a flat spot on this thing.
is one of the wires longer than the other one?
It is, yeah.
Uh,
That's ground, right?
I can't remember which wire is ground. The shorter wire is the negative lead, which goes to ground.
Oh, dang it. I wired all these backwards.
Okay.
That's really frustrating because the RGB LED, the ground is the longest one. Dang it, anyhow. It got me. I made an assumption and it burned me. That's what happens with assumptions. So I'm just reversing the polarity on all these. Just polarity being backwards on everything.
It's fine.
Was that a thing in Vermilion House?
It was.
That's hilarious.
I did not personally measure it, but the claim was that all of the outlets were wired backwards.
That's funny. Funny and bad. Okay, let's try that again. Hey, we have a heartbeat. Nice. Good job, gang. That seems so satisfying. Oh gosh. So excited. Do we want to attempt to do the other one right now, or do you need to go?
I think that I probably need to get going pretty soon.
Okay. Well, we have the framework in place, so next episode we will get the, or maybe before then I'll write up the if statement for it.
Sounds good. I think it is probably just a series of if, else statements to check low, high, and just right temperature and humidity.
Yeah.
And then inside of each one of those, control the correct LED.
And I would put that in the loop, you think?
I would put that in the loop, probably just after the if statement that acquires the temperature.
Would it be beneficial to put it inside of this if statement? Because this if
Well,
statement
let's
is
see.
asking, like, are we getting values? Right?
It does seem like it would be good to put it inside of the if statement because that is the only time you guarantee that you actually have values for temperature and humidity to check. Yes.
So I'm just going to write in here, this is where the pair of if, else, right?
If, else. Just a three-state if statement check.
Okay. Be careful writing long if-else statements, or if you're like me, you'll write is elf, and then you have a whole nother slew of problems trying to identify if things are elves or not. Thank you, V. Kruger. That is where we will stop for the night. Thank you so much, Zenhaver, for going through all of this with me. I learned a lot tonight, and I'm becoming more and more confident in this stuff thanks to your direction. So
No worries. This was fun.
I enjoyed it. So next week, I think we'll be maybe diving again back into the design if I made any modifications to the greenhouse design, and then working on either stepper motors or relays, probably focusing on relays, and I'll try not to buy any more parts between then and now before we can play with that. So thank you, and hope all y'all have a great night. I'm actually going to end our call straight away, Mr. Zenhaver.
Sounds good.
So y'all have a good night, and see everyone later. Where is that window? Okay. Ciao.